Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. Be sure to check out our sponsor, Jetbrains Rider, a fast, powerful cross-platform .NET IDE. Build, run, and debug ASP.NET, .NET Core, Microsoft.NET, or Unity applications. Take it for a free 30-day trial by going to cynicaldeveloper.com/rider. In this episode, we will be talking about integration testing, which it's a little bit like unit testing, but we're going to talk about what it is and how it actually differs from unit testing. And here to talk to us today are two guests rather than the normal one, and we've got John Callaway and Clayton Hunt. As a Microsoft MVP, John has been a professional developer since 1999 and has focused primarily on web technologies and has experience with everything from PHP to C# to ReactJS to SignalR. Clean code and professionalism are particularly important to him, as well as mentoring, teaching others what he has learned along the way. Clayton has been programming professionally since 2005, doing mostly web development with an emphasis on JavaScript and C#. He has a focus on software craftsmanship and is a signatory of both the Agile Manifesto and the Software Craftsmanship Manifesto. He believes that through short iterations and careful gathering of requirements, he can deliver the highest quality and the most value in the shortest time. He enjoys learning and encouraging others to continuously improve themselves. And together, they make up two parts of the Six-Figure Developer podcast. And I'll be putting a link to their podcast in the show notes for this episode. So welcome both to the Cynical Developer.
Thank you.
Thanks. Glad to be here.
Yeah, thanks for taking the time out to come on and talk to us today. And before we get into today's topic, do you want to jump in and tell us a little bit about the Six-Figure Developer? What's it about and where we can find it?
Sure. You can find us at sixfiguredev.com. And the podcast is primarily around professional topics, professional development, new and exciting technologies, TDD, clean code, and the like. So we primarily revolve around anything to help you improve your craft and continue to advance in your career.
Awesome. It sounds like it's quite a nice complement to what we're doing here on the Cynical Developer. And I say we, that's the royal we, that's me, and the people we have on the show. But unlike the Cynical Developer, there's more than one host for your show. That's right.
Yeah. There's currently three of us, and we all met and worked together in Louisville, Kentucky, many years ago, and have since all kind of scattered to the winds. Clayton and I are both down in Tampa, Florida, and John Ash, who is our third host, has moved up to the Columbus, Ohio area.
Sure. So there'll be a link in the show notes to follow for any listeners out there that want to jump in and get involved with the Six-Figure Developer podcast as well. So we're going to jump into today's topic, which is integration testing versus unit testing. Now, we did do an episode on unit testing quite a while back, and if listeners want to go and check that out, then go and have a look on the website for that. But we'll cover it a little bit here. So we'll jump in with what is unit testing?
Unit testing is just more code. It's pretty simple. It's just you write some code that will run through your code to make sure that your code is doing what it's supposed to do. And specifically, the unit part of unit testing is the ability to run your code in isolation from the other tests.
Sure. So you are taking all those individual pieces of code that you've written, and probably the smallest piece is down to functions, but normally you're doing classes. You're testing classes on their own. They may have dependencies on other classes within your system, but you mock them out with a framework or however you want to do that. And you are just testing that on its own, that single unit. And I think that's the key there. It's the smallest unit.
Right.
So how does that compare to integration testing? How is it different from unit testing?
So integration tests And integration testing is more the testing that the individual units of the application work together. So you might be testing that part of your business layer is working with part of your data access layer or your UI layer or whatever the case may be. So it's kind of that next broader step. So I've seen this diagrammed as kind of a pyramid where you might want to spend more time and more effort in developing unit tests than you might, and because they're a little bit smaller, a little bit cheaper, less costly to write and maintain. Then you might move up that pyramid and have fewer integration tests where they're a little bit more expensive and a little bit more comprehensive, and you might have fewer of them across your system.
Right, so you're taking multiple pieces and putting them together, whereas with the unit testing, as I said, you mock those out. You actually stick those dependencies together in their concrete forms and test them as a whole, I guess.
Right, exactly.
So you're not going to be testing the whole application. It's not end-to-end testing. You're, as you said, you could test maybe your data access layer with maybe your transformation from a model to a DTO and pass that through to the data layer. Would that be sort of like a good assumption?
Yeah, that's a good example.
Okay. So is integration testing the same as functional testing?
Some people would say yes. I tend to think of the functional testing to be more like an end-to-end, where you're starting at the user interface of the application and just seeing if a function that you're trying to accomplish within the app works all the way through. Whereas typically what I would call integration testing is testing an integration point between your code and some third-party resource. Could be a framework that you're using, or like you were saying earlier, the database, or even a API that you're calling that's external to your system.
Sure. So we're talking about, John was mentioned a pyramid there. Is that pyramid then unit testing at the bottom, integration testing the next layer up, and then functional testing at the top of that? Is it a little bit different to that? Is it a bit bigger than that?
Typically, I see like UI tests at the top. So maybe like a coded UI testing framework, maybe a Selenium or something like that.
Sure.
And those are often going to be rather expensive to set up and maintain. And you're probably going to spend much more time and effort on those types of things. So you're better left to work at that lower level where you can catch errors sooner and you can deal with them more quickly and a little bit more cheaply.
Sure. So in unit testing, we write the tests first, at least when we're doing TDD or pseudo TDD. We write the code until the tests pass, and it's some sort of iterative process to get that unit testing done. Is it a similar approach with integration testing, or is this a wait till all the unit testing is done, wait till you've got a piece that is working on its own and stick them together and then see if they work together?
I'd say it depends on which part of the application you're integration testing. With something like the database, I'd say you could definitely do it in a TDD style, especially in languages like C# where you're using entity framework. You can actually build up the data model in a test-driven way before actually creating the database. However, if your integration point is the UI, you just want to check between your, let's say you're, again, in C# and you're working in an MVC environment. You want to test the operation between your controller and your view. That one, because views, the user interface is so mutable, it changes, it's all finicky. You might make the user interface the way you want it to look and B, and then write the test after the fact, because you won't know the particular div or element that you want to attach the test to until after you've already made it.
Right. Okay. So do you still mock certain parts of your tests out? Do you write them the same way as you would write a unit test?
I would say mock anything that is outside of the point of integration that you're wanting to test. So in the example of writing an integration from your MVC controller to your view, I would say mock out the service layer. Mock out whatever your business logic is doing. The only part that you care about is that the click interactions and stuff like that is working in your view. So you don't really care that your business logic is running correctly. You only care about the interaction between your controller and your view.
When I'm sort of, I don't know if teaching is the right word, but when I'm instructing people about unit testing, they tend to initially get a little bit carried away, and then they want to sort of test a third-party endpoint, or they've got a third-party library that they want to test. And I always say, you're missing the point. Unit testing is about testing your code. It's not about testing their code. So their code could be a third-party library. It could be the .NET framework. As I'm a .NET developer, so I can talk from that point of view. Do you actually test those third-party points with integration testing, or do you still just go through the point where you assume that functionality does what it says in the tin?
Yeah, I would say it's important to know what the possible behavior of that third-party system is. So if you know that you can expect that given the certain scenario, you will get back a response of true. Given a certain scenario, you might expect to receive some kind of exception. So as long as your code can handle the known responses from the third-party integration point, then that's what I would focus my attention on. Then if perhaps you do encounter a bug that you got something that you absolutely did not expect to get from that third-party system, that's just an additional test that you need to write. And then, of course, handle that new exception.
Clayton mentioned about using Entity Framework and doing integration tests there, where it creates a database, it populates it, it seeds it with its data and things. How does that work in a build environment? Because with the likes of VSTS, we can run all our unit tests and they pass and they don't really build anything. Do you have to then build something up around it to say, we need to spin up a server, or we have a server somewhere that will be used to spin up a new database on? How does that work?
Yeah, I'm actually in the middle of working with a new client right now. We're doing a single page application with React in the front end with Web API, .NET Core backend. We've written all our unit tests for the UI project, for the React project. We've written all our unit tests for the Web API backend and the business layer, of course. And now we're starting to focus more on integration tests. Of course, we set up our CI/CD pipeline, and we're running our tests every time we commit and merge to the branches. So we're looking at what additional checks and balances we need to have in that. So as we add more integration tests, there are certain tools that we can look into. We can start to look at thresholds for code coverage if we need to, but along the lines of testing integration with something like a database, we are using Entity Framework Core. We could use something like an in-memory provider, where we could see that in-memory instance and then run any of our integration tests against that.
Right. Okay. So taking that example, if you are using an in-memory version of the database, is that not testing a different path to what you would use in the actual application? So you're testing a different truth to what the real world application will use?
Yes and no. Anytime you're substituting a mock or some kind of substitution for a third-party piece to the application or third-party integration to the system, then you are essentially testing something that's not the source of truth. With something like testing with an in-memory database, we're still using our entity models that we've defined within the application. We're still testing with the data that we have set up to provide for expected behavior and expected outcome. So, we're still doing more good than not doing these things at all. When you try to test with something like a full SQL server and set up test data, then you're going to be having all kinds of unexpected behavior or side effects to your testing that might provide some false positives as your integration suite runs.
Sure. Okay. The integration tests, do you run those every time, the same as unit tests are run? Do they run every time there's a build, or are they only run on certain builds or at certain times?
This is something that you'd have to discuss with your if you have a DevOps team or whoever's managing the build process. As a developer, as long as the integration tests don't take a really long time, by all means, run them as often as possible. However, they are integration tests. So if for some reason the resource that you're integrating with, like say you've got a backend API that is fully within your company's control, maybe you've got microservice API architecture with some kind of SPA as the client in a browser. And for your unit testing and integration testing of the SPA, you actually want to connect to the test version of that API. So you might have that set up, but there's the possibility in the test environment that API could go down. And you don't want to fail your application simply because that API went down. So that's why you have to work it out with your DevOps or whoever's managing your builds. You may run them only on a trigger, so maybe a QA can run them, but they don't run as part of the build. Or you might run them as part of the build and realize that there's a certain percentage of fail rate, and as long as the fail rate isn't exceeded, then the build is accepted. You could also just reject them outright if that's what your team decided on. But even in test, if they do take a long time to run, then I wouldn't suggest running them all the time. I like to keep the integration tests in a separate project from the unit tests. That way I can turn one on or turn one off if I need to.
Sure.
Yeah, I would never want to get in the scenario where they take too long to run, so we're just not going to run them, or we run them and 60% of the time they fail, but we know that that's the case, so we'll go ahead and pass it. We want to make sure that we're providing value and that we can depend on our suite of tests, whether they be unit tests or integration tests, to provide that level of comfort in deploying and delivering quality software. So if we can't rely on the validity of that test scenario, then it's not providing the value that we need from it.
Sure. And you mentioned before that UI testing, automated UI testing through the likes of Selenium and WebDriver and all that sort of thing, that they are quite costly to produce, to maintain. Now, on the other end of the stick, you've got unit tests that are really sort of low cost to maintain, but they have a high value because they catch errors really early and really quickly. Is that the same for these integration tests? Do they carry the same sort of ease of use, ease of fixing, and do they raise these problems fairly straightforward and fairly easily to developers so that they can get in there and fix them?
Yeah, I would say as long as they are providing that value and they are being run often enough to cover a developer as they may be moving code around and potentially introducing defects, then by all means do that, because these are all tools that we have to produce quality software. So we want to make sure that we're using all our available resources.
Sure. So we've got a lot of these testing frameworks out there for use in writing unit tests. Is it these same frameworks that we use to write these integration tests, or should we be using something else? Is there another technology that we should be using for that?
Well, like you mentioned earlier, often when doing integration tests, you have to plug in at least a third party that will work with the same tools that you use for unit testing, like Selenium, or in Angular, you would use Protractor to do end-to-end and integration tests. So there's almost always an extra piece of tool set that you would have to add in order to do those kinds of tests.
Sure.
Yeah, and what's the one for React? Is that
Enzyme?
Enzyme, right. Yeah, so that's another option that you can actually, another tool to put in your tool belt.
A quick word from our sponsors, .NET developers. Have you tried JetBrains Rider? It's a cross-platform .NET IDE that is light yet powerful and comes from the makers of ReSharper, IntelliJ IDEA and WebStorm. Regardless of whether you write .NET code for Windows, Mac or Linux, Rider has you covered. Rider helps you develop ASP.NET, .NET Core, .NET Framework, Xamarin and Unity applications. Most of the languages used in .NET development are supported from C#, VB.NET, F# and XAML to ASP.NET, Razor syntax, JavaScript, TypeScript and all the other essential front-end goodness. It comes with navigation, thousands of code inspections, refactorings, unit testing, debugging, coding assistance, and more advanced IDE features, powered by the proven technology from ReSharper and WebStorm. Download Rider now and take it for a 30-day trial at cynicaldeveloper.com/rider. Something that I've come across rather recently is that we've built a system, it's unit tested, the tests all run great. Each of the individual pieces, they run fantastic in isolation as a unit. And as soon as we put them together, things started falling over and they weren't working as we expected them to work. And I guess this is where integration testing would come in and would save us from ourselves, I guess, a little bit, because we would know straight away that maybe the way that we've implemented the logging system or the way that we've decided to implement our message queuing system was slightly flawed before it got down to the crunch of half an hour before we needed to deliver this project. We stick it all together, we go, right, let's do a quick end-to-end test, and the whole world comes collapsing down around us.
Yeah, I would say, especially these days when certain architectures and certain buzzwords are all the rage, where everyone's looking into microservices and disparate systems, that it is increasingly important for these teams and these individuals that are working on different pieces of applications that will be integrating with each other to collaborate and to communicate and make sure that that they both have the same understanding of how those systems will interact with one another and work earlier and more quickly together, or try to come together more quickly and earlier, so that you don't just develop those systems in a vacuum.
Sure. So currently, if you're doing TDD, you write your tests to follow the acceptance criteria that you're giving on your stories or tickets or whatever is in your tracking system. Do you use those same criteria for creating your integration tests, or do you need a different set of data for that?
It depends on, I guess, the style of testing that you've decided to go for. If you're doing the style of testing where you take the acceptance criteria and you write a test to meet the acceptance criteria, then that test should allow you to follow all the way down from whatever your user interface point is all the way down to whatever your data source is. And you might have several tests supporting that acceptance criteria, but the single acceptance criteria should work. If you're like most developers, what you'll end up doing is writing what I refer to as developer tests. So it's not I have this business goal that I'm trying to meet. It's I know this function needs to do this thing. When you are writing tests at that level, you're not going to follow the same path for doing an integration test as you would if you were doing acceptance criteria. Your integration test at that point is, I know that this API will return or can return a 500. So when I get a 500, then I know that it's going to throw, and I want to throw this error exception that we've determined is the right one, and I'm going to pass that up the call stack, as opposed to in the event that we are unable to retrieve the user data, then the system will tell us that user data was not found.
Yeah, and that's a good chance to kind of audit your unit tests as well. I mean, as you've developed that system, you kind of know the inputs and outputs of particular methods and classes and features of the system. So when you're integrating those different pieces together, you can say, I know that this one outputs this value, and then this particular method might expect that value, and how is that going to behave, and how is that going to be handled? If you come into a case where something isn't being handled properly, then it's easily discoverable and easily mitigated by just adding an additional unit test to cover that particular feature or that new behavior that was discovered.
Sure. So you should be, as well as testing your super duper happy path, you need to be writing integration tests for the failures, for the problems. So at least you know that your system can handle those when these pieces are put together as well.
Yeah, absolutely. And Uncle Bob would even say to test the failures first.
Right.
So what's all the stuff that could go wrong? Make sure that if it does go wrong, you have it handled, because that's the stuff that you're going to forget about if everything's working. And then your code might have huge holes in it that you're not aware of. Yeah.
Yeah, and I think taking that route, it can look a bit obtuse, a little bit odd when you go in and look at the unit tests. So I've recently written an API, and the endpoint is a single endpoint with a get on it. It doesn't accept a post, put, a delete, or any of the other different HTTP posts. But I have a single happy path of this is the post, and then there's like another 30 unit tests that are all failure tests. And you go through and you think, why are you even testing these? Well, it's because it's possible to send these requests through. I want to make sure that it just doesn't respond to any of those.
Right. Yeah.
For those that have listened to the unit testing episode, and I know I keep banging on about unit testing here and doing the comparison, but that's what this is about today. What are the benefits of doing integration testing? Now, these might be quite obvious, but being cynical and being a little bit stupid, can we spell out what the benefits are going to be of writing integration tests?
For me, I would say the largest one is that contract between the systems. So earlier you mentioned that you might have a team doing logging and another team doing some business scenario and another team doing some other thing. And when you all come together to integrate, everything just goes bad. And that's because you don't have a solid contract between the different points of integration. With the integration tests, you can confirm and, you can assert and confirm that contract. These are the methods that get called. These are the expected outputs. If something goes wrong, these are the expected error cases. And all of those things will protect you from that integration day panic when things don't work.
It also provides you a certain level of security from introducing any defects from regression. So I know that we've never experienced as developers and professionals users changing their mind or the business people coming to us and requesting a change after the fact.
Never.
So with those tests in place, we can assert and we can assure the business and the user and the client and the people that are paying the bills that Yes, we can do that, and as far as we know, we are not breaking anything to do this. Or we can almost immediately say we made that change and we broke other parts of the system because now we are changing the behavior of the system, or we're changing the understanding of the system. So that's another opportunity to have that conversation of, is this a legitimate change? Is this a new feature or a change request? Or is it simply an oversight that we forgot that that's the way that
Sure.
thing worked?
Sure. And Clayton mentioned there about different teams working on different projects. And I've been recently working on a project with an offshore team. Now we've built all our unit tests. We've done a little bit of integration testing. What we haven't done integration testing is with their system. All we've been told is this is how our system works, which they are still developing at the moment. And when it came down to the crunch time, and we said, right, we're ready. Let's do this test. Let's show that this works. And I went and I ran my unit test to actually go and ping some data over to them. And it failed because the way they'd said that they wanted to accept our information was actually different from how they'd implemented it. And their implementation was a little bit wrong as well. I think if you're developing at the same time, I don't think this is going to save you from each other, is it?
If someone tells you that they're implementing a particular contract and you write your code to follow that contract and then they don't, I mean, there's not a whole lot you can do at that point. Probably the best thing in that scenario would be for one of the parties or both parties to kind of create testing stubs. So like, that your code will work with our system when these tests pass, and then forward that to the other party. And then they can just run those tests against their own code and see whether or not they're going to have a problem when integration happens. It would work best if both parties did it and then compared the testing suites to make sure that both of them agreed. But I think that's about all you'd be able to do. If one party is willing to provide false information,
Sure.
then there's not really much that can be done.
Yeah, and we're only human, so mistakes are going to happen, and things might have gone wrong on accident, or things might have been changed as a result of any number of conversations or meetings or requirements. So with that being said, we change our understanding of what the integration is. We make adjustments to our suite of tests. We make adjustments to the code. We move on. All of these levels of testing aren't there to prove correctness. They're there to assure that we have identified points of failure and that we're passing those known points of failure.
Yeah. You can't fix stupid and you can't fix liars, as I like to tell people. It doesn't always go down well, especially if you're talking to the person that you're calling stupid. But that's a different show entirely. So I think we touched on it a little bit earlier, but I just want to clarify this. When I'm writing unit tests, I like to use the testing framework XUnit. I like to use Mock and a few other frameworks around that. Now, they make testing so much simpler. They make it easier to read through the test because you can see exactly what they should be doing. And if you're using something like should on the in your tests with Mock, non-technical people can read it and they understand straight away what that test is doing, rather than having a lot of these asserts, because assert isn't that obvious to non-techs exactly what that's doing. Now, are there frameworks that help with integration testing, or should we be just using the same frameworks that we're using for writing our unit tests?
I typically use the same frameworks that I use for unit tests to write integration tests. As Clayton mentioned, it's just more code. So we're dealing with things that we're comfortable with. So if you're using something like XUnit, then continue to use XUnit. Clayton and I both are historically .NET developers, and he introduced me to nCrunch. So I run nCrunch, and it'll keep track of my keystrokes and keep track of changed code and find out all of the tests that could be affected by that change, run only those tests, and it'll keep me pointed green on passing. So, tools like that often help point out potential failures and
Sure.
Failing unit tests.
I'm a big advocate of ReSharper. I know you can turn on active unit tests running, but if you're using ReSharper with Visual Studio and you haven't got the beefiest laptop that money can buy, I think turning on the live unit testing is going to grind your laptop to a halt. So I don't have that turned on when I am in Visual Studio. I tend to live in Rider at the moment, but I'm not sure if they've actually got live unit testing within Rider. They might have, and I haven't seen it. Because I know there's a few other little bits that we get that like .cover works natively in Visual Studio, but we don't get that in Rider just yet.
Yeah, last we checked, one of our guys here is using Rider, and he is suffering in a bit of pain because .cover doesn't work in Rider, and for some reason on his machine, the unit test projects are running much more slowly than they are on my Windows laptop in Visual Studio 2017 with ReSharper enabled and nCrunch.
Oh, well, there we go. Yeah, I really had the issue with that. The reason I use Rider over Visual Studio is just because of the blistering speed difference. It's just so much faster than Visual Studio at the moment.
If you're willing to go over to the dark side and run something written in JavaScript, or actually TypeScript, with the new .NET Core 2.1, you can actually watch your test suite just from the command line in VS Code. Do a .NET watch test, I think, and it'll run the tests continuously as you save.
Yeah, VS Code is something I've used, and I tried to force myself to like it by uninstalling Notepad++. I tend to use it mainly for markdown work. If I'm doing any like static baked sites using JBake or anything like that, I'll use MS Code. But for most of the things, I do reside in Rider because it's like a home away from home from Visual Studio. All your same shortcuts work and stuff like that. I have played with WebStorm, but I felt myself drowning very quickly because my shortcut keys didn't work, and I had to keep stopping and thinking and looking up how to do certain things. And I think that was one of the drawbacks for VS Code for me, was the fact that trying to learn what the shortcut keys are, they're not that apparent, and to find out you've got to go and look them up online. But maybe that's another show right there, ranting about different IDEs and where their shortcomings are. But back onto the topic for today's show. If listeners wanted to learn a little bit more about integration testing, do you have any links to any good courses or blogs or videos or any other resources that you can think of that would be of any use to them?
Well, of course, we did just write a book, Practical Test-Driven Development Using C#7, where we cover a little bit of integration testing in the book. About half of the book is JavaScript as well, even though C#7 is primarily in the main title there.
Cool. We'll definitely get some links to that in the show notes. Is that available on your Six Figure Developer website?
We've got links to it all over the place on the Six Figure Dev website. Of course, you can find it at pact.com, I believe, and of course through amazon.com.
Sure. And is that written by yourself and Clayton, or more people, or just you?
Clayton and myself.
Right. Great stuff. I shall go and add that to my wish list on Amazon. That wish list of books seems to be growing and growing by the day. I need to stop listening to audiobooks and start actually reading some real books.
Takes too long.
Yeah. There is that. I've got the Game of Thrones series in books to read. I think I've read the first 3 chapters, and I bought that on a Black Friday about 3 years ago.
Yeah, audiobooks you can speed up. I can't speed up the reading.
No, I'm not the fastest reader, but I do listen to audiobooks on 3 times, so I get through them pretty quickly.
Yeah, and you guys have more letters in your words.
Yeah, but you guys over the pond talk a lot slower, so we speed it up, and it sounds about normal speed. It does throw me a little bit when I do have guests come on and I talk to them, and I've been listening to their podcast, and I think, whoa, what? Why are they talking? Have they been doing substances they shouldn't have been doing? Are they a bit tired? What's going on?
Yeah, I'm listening to podcasts at about 2.2 speed right now, so.
It takes that little bit at a time. I was at 1 speed, and then it was like 1.2, 1.4, 1.7, and you build it up. And then when I have a bit of a break away from listening, I have to bring it right back down to sort of like 1.5 speed, and then I slowly build it up as I start listening again. Yeah,
I've recently had to do that. I was up at 2.5, and then life got in the way, so I didn't listen to anything for a couple weeks. And coming back to it at 2.5, I was like, I can't understand anything, so I had to drop it back down to, I think I'm at 2 right now.
Sure. Yeah, I have been known to walk around the house with my mobile phone on, playing a podcast or an audiobook at 3 times speed, and the wife just sort of looks at me really oddly. What the hell is that you're listening to? Because all she can do is I was like, well, it's an audiobook, But yeah. Anyway, I will not take up too much more of your time. I think it's been good. It's been informative, and it's definitely cleared up a few of the points for integration testing that I had. I think I was maybe confusing it in my own head as functional testing. So I think from today onwards, I've got a better understanding than that, and I hope the guys and the girls out there listening have as well. If anyone out there has got any comments that they want to put to Clayton and to John, then do leave a message on the show, and I can push it over to them and get an answer for you. And I'm sure they'll be able to jump onto the show notes as well and reply to you.
Yeah, absolutely.
Fantastic. Thank you all for listening to Cynical Developer. I'm James Sluddart, and you've been listening to John Callaway and Clayton Hunt talking about integration testing. Our sponsor JetBrains are here to help you fight against all types of memory issues in ASP.NET, .NET Core, and .NET Framework applications with .memory Memory Profiler by JetBrains. Insightful views, Visual Studio integration, automatic snapshots, a command line profiler, and a free unit testing framework. A free trial is available at cynicaldeveloper.com/.memory. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help the Cynical Developer to reach more developers around the globe.